Have you ever just been scrolling, online and you come across something so strange that you just have to know more?
Oh yeah, all the time.
For me lately, it's this whole flat earth thing.
Really?
It is wild how many people actually believe it.
It is.
Like the numbers are pretty big.
Yeah. What have you seen?
Well, I've seen reports saying something like 10% of Americans actually think the earth is flat.
Wow, 10%.
Yeah, and then around 3% in the UK,
Mm,
and get this, a whole 7% in Brazil.
that's a lot of people.
It is. And it's not like it's just one type of person or anything.
All right.
I mean, there was even this story about a PhD student in geology.
No way.
Yeah, in Tunisia. And they were trying to argue for a flat earth in their thesis.
I mean, that's got to be tough, right? To be studying geology and believe that.
I know. It really makes you stop and think, like, why is this still a thing?
You're right. I mean, in this day and age, with all the technology, we have satellites sending back images of Earth. You know, people have literally been to space. So it really is fascinating that this idea is still around.
Yeah.
It makes you think about, how we as humans process information, how history plays a role, and really the power of belief.
That's a great point. And that's exactly why we're doing this deep dive today.
Okay.
To really unpack this whole flat earth theory.
Mm.
What are people actually saying? Where did this movement even come from? And I think the biggest question is why do people still believe this in the 21st century?
Yeah, it's a great question. We have some interesting stuff to look at today to try and figure that out.
So where should we even begin with all this?
Well, I think a good place to start is with the historical context, because this whole idea of a flat Earth is not actually brand new.
All right. I kind of just figured it was a recent thing.
Yeah, you'd think so, but it goes way back. Like way, way back to ancient Greece.
Okay, wow.
Think about Pythagoras, around 500 BC. Now, he didn't have, telescopes or anything like we do today, but he was looking at the sun and the moon,
Yeah.
and they were round. And so he basically made a guess that the Earth must be round too.
That's a pretty good guess for back then.
It is, right, just based on what he could see.
Wow. Then what happened? Someone had to actually try and prove it at some point.
You got it. So a few hundred years later, you have Aristotle around 350 BC, and he started to gather some actual evidence.
Okay, how so?
Well, he noticed something interesting during lunar eclipses.
The shadow?
Yeah, the shadow that the Earth makes on the moon. It was always curved, no matter what.
So he figured that means the Earth itself must be curved.
Exactly. He also noticed something that I'm sure you've seen before, too. When ships sail away, over the horizon.
Yeah, they disappear hull first.
Exactly, like they're sinking down.
Right.
And that also suggests that the Earth is curved.
It all makes sense when you put it like that, but still hard to wrap your head around.
Yeah, well, then you have Eratosthenes. This guy was a total genius.
I've heard of him. He was the one who figured out the size of the Earth.
You got it. And this is back in like 200 BC.
Using just sticks and shadows, right?
It's amazing, isn't it? He basically realized that the angle of the sun's rays was different in two different cities at the same time of day.
Oh, I see, because the Earth is curved.
Exactly. So he used that angle and the distance between the cities to calculate the Earth's circumference.
And he was pretty close, right?
He was unbelievably close. His estimate was somewhere between 37,500 kilometers and 50,000 kilometers.
Wow.
And the actual circumference is about 40,075 kilometers.
That's incredible for over 2,000 years ago.
It is. It's mind-blowing. So you can see that the idea of a spherical Earth has been around for a long time, and with pretty solid reasoning and evidence.
Yeah. So where does this whole flat Earth movement come in?
Well, it kind of picks up steam again in the mid-1800s. There's this guy named Samuel Rowbotham,
Okay.
and he writes this book in 1865 called Zetetic Astronomy, Earth, Not a Globe.
It's pretty straightforward.
It is. And this book basically becomes like the Bible for modern flat earthers.
Okay, what was he arguing?
Well, his whole thing was based on what he could see with his own eyes. He'd look out at the horizon, over a lake or something.
Yeah.
And it looked flat to him.
It does, though, doesn't it?
Right. So he figured if the Earth was really a sphere, you should be able to see the curve.
I guess I can kind of follow that.
Yeah.
But, I mean, there's got to be a reason why we don't see the curve, right?
Well, yeah, there is. But Rowbotham's approach was all about believing only what you could directly observe. He called it zetetic.
So no fancy science, just what you could see.
Right. He thought if you couldn't see it, it wasn't real.
Okay, so if the Earth isn't a sphere, then what did he think it looked like?
Well, he imagined the Earth as this flat disk with the North Pole in the center. And then what we know as Antarctica. He thought that was a giant wall of
A
ice.
wall of ice.
Yeah, surrounding the whole outer edge of the disk.
Like a barrier.
Basically, yeah. He thought that's what stopped people and the oceans from falling off the edge.
Makes sense if you think about it like that, I guess. But what about the sun and the moon? How do they work in this flat Earth model?
Okay, so flat earthers believe that the sun and the moon are much smaller than scientists say.
Oh, really?
Yeah. And they're also much closer.
Okay, so instead of these giant celestial bodies millions of miles away,
They think they're more like spotlights moving in circles above the flat Earth.
like they're shining down on us.
Yeah, and that's how they explain day and night.
The spotlight moves, creating day and night. That's a pretty interesting visual.
It is. And there's a guy named Mark Sargent who has this model where he says the sun and the moon are only about 50 kilometers in diameter.
Wow, that's tiny.
I know, right?
Yeah.
And he thinks they orbit at a height of like 500 kilometers.
That's a huge difference from what science tells us.
It is a massive difference. For comparison, the sun is actually about 150 million kilometers away.
Yeah, and the moon is something like 400,000 kilometers away.
Exactly. So in their model, everything's way, way smaller and closer.
Okay, I'm following. But how do they explain the seasons? If the sun and moon are just going in circles above us, wouldn't it be the same temperature all the time everywhere?
Well, they say that the paths of the sun and moon change throughout the year. Like their circles get bigger and smaller, or they shift position or something.
So that's how they get summer and winter.
Yeah, that's the idea. They say that causes the difference in daylight hours and temperature.
Okay, and what about Mark Sargent? He has his own theory about sunlight and moonlight, right?
Oh, yeah, he does. It's kind of funny, actually. He basically says that sunlight is hot and moonlight is cold. Because, if you stand out in the sun, you feel the warmth.
You do.
But then if you go out on a clear night with a full moon, it feels cooler.
Yeah, true.
So he says that proves sunlight and moonlight are fundamentally different.
They have different properties.
Yeah, and that supports their idea of a smaller, closer sun and moon.
It's an interesting idea,
Yeah.
but, wouldn't that mean the moon has its own light source or something?
Right. It doesn't really make sense when you think about all the other stuff we know about how light works.
Yeah, like moonlight is just reflected sunlight.
Exactly. And there are so many factors that affect temperature, like the atmosphere, the time of day, the Earth's rotation.
It's way more complicated than just feeling the sun or moon on your skin.
It definitely is. But for some people, that simple observation seems to be enough.
It's like they take that one piece of personal experience and make it the foundation for their whole belief system.
It's true, and that's something we'll talk more about later. But for now, let's move on to something else that flat earthers use to support their claims.
Okay, what's that?
Religious texts.
Oh, yeah. I've heard they try to find proof for a flat earth in the Bible and the Quran.
Exactly.
Yeah.
They take these ancient texts and interpret them very literally.
So they're looking for scientific facts in poetry and metaphors.
Basically, yeah. Like there's this passage in the Bible in Revelation 7.1. It talks about 4 angels standing at the 4 corners of the earth.
Oh, I've heard that one.
Yeah, and flat earthers take that to mean that the earth literally has corners.
So it can't be a sphere.
Right. But most scholars interpret that phrase to mean something more like all parts or the extremities of the earth.
Like a figure of speech.
Exactly. But flat earthers tend to ignore those interpretations.
So they pick and choose what fits their theory.
It seems that way. There's even an old map from 1893 that shows the earth as a square with angels at each corner.
Wow, people were taking that literally back then, too.
It seems so. And it's not just the Bible. They do the same thing with the Quran.
Like what?
Well, they like to quote Quran 71.19, which says that Allah made for you the earth like a carpet spread out.
Okay, I can see how they would interpret that as meaning flat.
Right, but again, most Islamic scholars throughout history have understood that verse to mean that the earth is vast and accessible for human life, not necessarily flat in its shape.
So it's more about the meaning than the literal words.
Exactly. But there have been a few dissenting voices over the centuries.
Who?
Well, there was this Saudi cleric in 2015 who said the earth is stationary and that the moon landing was a hoax.
Wow.
But those views are definitely not mainstream in Islam.
It's interesting how they try to use these religious texts to support their claims.
It is, and it kind of highlights how this belief is often tied to a bigger web of conspiracy theories.
What do you mean?
Well, it's rare to find someone who believes in a flat earth and nothing else.
Okay, like what other things do they usually believe in?
It varies, but a lot of them also think things like vaccines have microchips in them, or that NASA is faking all the space missions.
Right, like it's all one big cover-up.
Yeah, and some even go further and say things like gravity doesn't exist or dinosaurs never existed.
Really? It seems like once you start doubting one thing, it opens the door to doubting everything.
It does seem that way. And they even find evidence for their beliefs in everyday things.
Like what?
Well, they like to point to the UN logo, for example.
The UN logo.
Yeah, the one with the map of the world.
Okay.
They say that map proves the Earth is flat. Well, they say it's because the map is a flat representation of the world.
But I mean, all maps are flat, aren't they?
Right, but they don't see it that way. They ignore the fact that you can't perfectly represent a sphere on a flat surface.
So they're missing the whole point of map projections.
Exactly. And they also point out that Antarctica is often missing or minimized on those maps.
Oh, right.
Which they see as proof of the ice wall conspiracy.
Like they're hiding the edge of the world.
Yeah, any logical explanation you give them, they just dismiss it as part of the conspiracy.
It seems like it would be exhausting to live like that, always questioning everything and everyone.
I would think so. But let's move on now to maybe the most important question.
Okay, what's that?
Why? Why do people believe this stuff?
Yeah, I mean, with all the evidence we have today, why are people still clinging to this idea of a flat Earth?
It's a good question, and there are a few key reasons that we can look at.
Okay, let's hear them.
Well, first of all, there's convenience.
Convenience. What does that have to do with the shape of the Earth?
It's about how our brains work. We tend to prefer explanations that are simple and easy to understand.
Oh, okay.
Like science can be really complex.
It can be.
It takes time and effort to learn about things like gravity and orbits and all that. But the flat Earth theory, it offers a much simpler explanation.
I guess so.
It's like taking a shortcut.
Yeah.
It's easier to believe that the Earth is flat and everything's just as we see it.
Right, and it avoids having to confront all those complex scientific ideas.
Exactly. And it can also align with people's pre-existing beliefs.
Like what?
Well, for some people, it might fit better with their religious views or their distrust of authority.
So it's easier to just accept the simple explanation than to challenge your worldview.
Right. And that's what we mean by convenience. It's the path of least resistance.
Okay, that makes sense.
Yeah.
What about the second reason?
The second reason is intuition.
Intuition.
Yeah, our gut feeling about things.
Oh, okay.
And it plays a big role here because when you just look around you, the Earth does seem flat.
It does.
The ground is flat, the horizon looks straight.
Yeah.
So it's intuitive to think that's how it really is.
Right, and we tend to trust our own senses.
Exactly. And flat earthers often say, I don't feel the Earth moving, so it must be stationary, or the horizon looks flat, so the Earth must be flat.
So they're basing their beliefs on their personal experience.
Right. And they're ignoring all the scientific evidence that contradicts that experience.
I guess that's where critical thinking comes in.
You got it.
Yeah.
And that's actually the third reason, lack of critical thinking.
Okay, what do we mean by that?
Well, critical thinking is all about analyzing information carefully. Questioning your assumptions, evaluating evidence, looking at things from different perspectives.
Right.
And unfortunately, a lot of flat Earth proponents, they don't seem to do much of that.
So they're not really questioning their own beliefs.
Not really. They tend to just accept information that supports their view and reject anything that doesn't.
Even if it comes from a credible source.
Yeah, they might say things like, do your own research.
But they're not really doing research, are they?
Not in a scientific sense. They're often just looking for information that confirms what they already believe.
Like cherry picking.
Exactly. And there's a classic example of this with Samuel Rowbotham himself.
The guy who wrote the book.
Yeah, back in 1838, he did this experiment on a river.
Okay.
He claimed that it proved the Earth was flat.
How?
Well, he could see a flag at a certain distance that he thought should have been hidden by the curve of the Earth.
Oh, I see.
But he completely ignored the effect of refraction.
Refraction?
Yeah, that's when light bends as it passes through different densities of air.
Oh, okay.
So the flag wasn't actually where it appeared to be.
So his experiment was flawed.
It was, and later experiments proved that.
But he didn't want to accept that.
Right,
Yeah.
He was so convinced that he was right that he ignored any evidence to the contrary.
So that lack of critical thinking really seems to be at the heart of a lot of this.
It does, and then the fourth and final reason is mistrust of authorities.
Oh, yeah. That's a big one with a lot of conspiracy theories.
It is, and it's definitely a factor with flat Earth beliefs.
So they don't trust scientists or the government.
Yeah, they see them as part of this big conspiracy to hide the truth.
Right, like NASA's lying to us about space and all that.
Exactly. And they might also distrust the education system, the media, anything mainstream.
So where do they get their information from then?
Often from unreliable sources online.
Like YouTube videos and conspiracy websites.
Yeah, stuff like that. They'll believe some random person on the internet over a scientist with years of experience.
It's like they've completely flipped the script on what's credible and what's not.
It really is. And it's hard to argue with them because they just dismiss any evidence you present as being part of the conspiracy.
Oh, it's a closed loop.
Pretty much. And it's kind of sad because it shows how easily people can be misled.
Speaking of being misled, you know what story comes to mind here?
What's that?
Mike Hughes.
Oh, yeah, the rocket guy.
Yeah, what a wild story.
It is. So he was this limousine driver who became famous for building his own rockets. And at first he wasn't really associated with the flat earth movement.
But then he started saying he believed in it.
He did, and he even said he was going to launch himself into space to prove it.
Remember he said he wanted to see the shape of the earth with his own eyes?
Yeah, and he talked about this big ice wall in Antarctica.
Like he was going to fly over it or something?
It's crazy, right? Yeah. But the thing is, it seems like he only started saying all that when he needed money for his rockets.
So he was using the flat earth thing to get funding.
Pretty much.
Yeah.
He knew it would attract attention and donations.
And it worked.
It did. He raised thousands of dollars from people who believed in him.
But then, of course, he died in a rocket crash.
Yeah, it was a tragic end.
But here's the twist.
What's that?
After he died, people who knew him said he never actually believed in the flat earth.
Oh, wow.
He was just using it as a publicity stunt.
So he was deceiving all those people who were supporting him.
It's really messed up.
It is, and it makes you think about how easily people can be manipulated.
Especially when they want to believe something so badly.
That's a good point. So we've covered a lot of ground today.
We have. We talked about the history of the flat earth theory, how it's not really a new idea.
Right. It's been around for centuries.
And we looked at the specific claims they make about the shape of the earth, the sun, and the moon.
And their use of religious texts and conspiracy theories.
And most importantly, we explored the reasons why people believe this stuff.
The convenience of a simple explanation, the reliance on intuition, the lack of critical thinking, and the mistrust of authorities.
It's a fascinating and complex issue.
It is, and it really highlights the importance of critical thinking and media literacy in today's world.
It does.
Yeah.
With so much information out there,